Students, can you hear my voice? Student, can you hear my voice? Pranay? Pranay? Pranay, can you hear my voice?
Yes, sir, I can.
Pranay?
Yes, sir, I can hear your voice.
Okay, okay. Thank you. Okay. Good morning, students. Um, Last class we discussed that is the theory portion of second module. In the second module, we already discussed there are the two components are there. First one is soil structure and clay mineralogy, and second one is compaction of soil. Okay, these two, there are two subdivisions in module number 2 we can expect. First one is compaction on soil. What is the meaning of compaction of soil? Okay, compaction is an artificial process. Means it's not a natural process. Means artificially, with the help of mechanical equipment, with the help of manpower, we are compacting the soil. Means it's nothing but a densifying the soil. Okay, artificial process of densification of soil by reducing the void ratio, and hence a reduction in volume by expulsion of air from the voids of a partially saturated soil. If it is in partially saturated soil, obviously we can expect there is any water content. When you insert any weight or any pressure on the soil mass, okay, obviously it change the volume. Means obviously it is not increases the volume, it decreases the volume. It decreases the volume. Then we can explore the, means we can extract the, there is the air content as well as the water content. 100% water content we can expect, but air content is we can't expect a 100%. It becomes the densification, and we can remove the voids also. It is process brought by using the dynamic process like vibration, rolling, etc. Means it is in a dynamic process, not kinematic process. It is in a dynamic process. When you apply the load on the soil with the help of vibrators, rollers, okay, and hammer, if you give these number of, there is the effects on the soil, obviously it decreases the volume. Okay, that process we call it as a compaction. Compaction of soil result in reduction in permeability, increase the shear strength, and decreases the settlement. Obviously, compaction of soil results, when you go for the compaction of soil, what are the results we can expect? First one, we can increases the shear strength, means C and pi value. Shear strength parameters are C and pi value. C means that is the cohesion, and pi means angle of internal friction. C and pi value we can increase the values. At the same time, permeability means, for example, it is in a sandy soil. Okay, inlet and outlet we can expect, but it take limited time. Okay, when you go for the compaction, it take more time. It there is the water flow through soil. It take more time. Means it is nothing but a permeability. It can decreases the permeability. And next one is we can decreases the settlement also. When you go for the compaction, we can't expect there is any settlement. Okay, obviously we can improve the settlement capacity. Okay, these are the things we can expect from the compaction. At the same time, the degree of compaction is measured by dry unit weight and depends on water content and compactive effort. Means degree of compaction means what is the, how we can calculate the compaction, means with the help of dry unit weight. In the first module we already discussed, there is the gamma d value. With the help of the gamma d value, there is the dry density value, we can calculate what is the mdd. What is the meaning of mdd? Means maximum dry density, mdd value. And omc means optimum moisture content. Omc means optimum moisture content. Mdd means maximum dry density. We can calculate optimum moisture content. In some other textbook you can see optimum water content also, both are same. Okay, optimum moisture content and optimum water content we can expect. And next one is maximum dry density, mdd value also we can expect. And we can go for the compaction. Means compaction we can expect by weight of hammer. How much weight of hammer we are putting on this soil, there is the weight. For example, if you put 2 kg of hammer, and 5 kg of hammer, you can see there is a difference when you insert the 2 kg of hammer on this soil. Okay, that is the compaction and settlement of soil is little bit. But if you put 5 kg, you can expect more. Means weight of the hammer also act as an important role, and number of impact means number of times that is the rollers are moving from the one point to another point. First time it's moved from the one point to another point, means you can see there is a large number of centimeter. Second time also you can expect large, and third time, fourth time, means when you go for the number of rollers at a same time, it decreases the settlement number of rollers and number of passes. I told you from A point to B point, how many numbers you passes from A point to B point. Okay, and the next one, so you can see here, without compaction and the with compaction. In the diagram you can see without compaction during the work time, you can see there is the white gaps, it's nothing but a voids. Okay, when you compacted the soil at the same time, see here, you can see there is a volume is reduction, at the same time voids also reduces. Next one is, what is the objective? Why you are conducting this compaction experiment? What is the objective of this compaction? To increase the shear strength and before its bearing capacity. Means first one is, we can increase the shear strength parameters. I already told, discussed, there is a shear strength parameters or C and pi value. It's nothing but a cohesion and angle of internal friction value. C and pi value. And bearing capacity, safe bearing capacity and ultimate bearing capacity. During your BMCT subject, that is the building materials construction technology subject, BMCT subject, when you was in third semester. Okay, bearing capacity. Before, if you want to design any foundation, any footings or any civil engineering structures, first you have to find out what is the bearing capacity. How we can calculate the bearing capacity of the soil? In the first module we discussed. Okay, density, core cutter method and sand replacement method. If you want to calculate the density of material, that is the soil surface, okay, with the help of the core cutter method and the sand replacement method, you can calculate. Where you are using the core cutter method? Anyone students? Where you are using the core cutter method? Anyone students? Where you are using the core cutter method? Anyone? Where you are using the core cutter method? Pranay? 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 Pranay is not there here. Pranay Reddy. Pranay Reddy. Students, can you hear my voice? Anyone? Please reply.
Yes, sir.
Pranay
Yes,
Reddy.
sir.
Pranay Reddy. Okay. Where the coarse aggregates are present, means for example during highway construction, you can see only coarse aggregate is nothing but a boulders are present in a surface. You can go for the sand replacement method. Where the soils are present, clay soils or silt soils are present, you can go for the core cutter method. In examination also they will ask, where the coarse aggregates are present, how you can calculate the field density. With the help of the sand replacement method, you can calculate the density. Where the fine aggregates are present, silt and clay contents are rich and the soil, there is an absence of coarse aggregate, then you can go for the core cutter method. Here, bearing capacity, you can calculate the bearing capacity, SPC of the soil, then you can design the, that is the foundation. See, for the any natural soil, there is any compaction is required. Without compaction, if you constructed the foundation or if you design the any civil engineering structure, day by day you can expect there is any settlement. There is any settlement, then you can expect the unequal settlement, then you can expect the failure in the structural components, whether in the column, beam, slab, you can expect there is any failure in the structural components. And next one is the increases the stiffness and thereby reduces the future settlement. We already discussed, when you compacted, you can expect there is a stiffness, rigid surface. You can expect the rigid surface. At the same time, you can expect you can't expect there is any unequal settlement, because already you compacted, you remove the air voids and the water voids, those kinds of voids. Okay, then you can't expect there is any settlement when you apply the load on soil. Okay, and next one is to reduce the subsequent settlement under the working load, we already discussed, and to reduce the soil permeability, making it more difficult for the water to flow through soil. Means another one is, we can, after the applying the load or after the compacted the soil, then we can reduces the permeability. Means how we can reduce the permeability, means there is a simple examples, coarse aggregate as well as the soil. Okay, in a soil you can pass the water from the one end to another end within a fraction of time, because you can expect the more voids. Okay, at the same time, when you insert the water in a soil from inflow, from one end to another end, it takes some time, because at the same time in a soil voids are very less. Okay, and another one is there is the small particles, it is completely filled in the voids like silt and clay contents. So that wise, when you compacted the soil, okay, you can minimize the voids, at the same time you can decreases the permeability. That is the main objective of compaction. Means these are all important objective of compaction. In examination also they will ask define compaction and list out the objective of compaction. You can expect this question in examination 8 to 10 marks. Okay, any doubt students, any doubt students, any doubts?
No, sir. No, sir.
Okay, thank you Pranay. And next one is, what are the factors are affecting the compaction? Means what are the things you can expect? What are the factors affecting the compaction? First one is, the number of factors will be affect the degree of compaction that can be achieved. First one is the nature and type of the soil. Means, for example, okay, if you want to construct the road in a North Karnataka as well as the South Karnataka, okay, as you know, North Karnataka is completely covered with the black cotton soil, and the South Karnataka you can expect there is a red soil. Means North Karnataka black cotton soil means Mont soil. We discussed in the last class. Okay, black cotton soil we call it as a name Mont soil, and red soil we call it as a name Kelnotic soil sample. When you compacted this soil, okay, there are the different category of soils we can expect. For example, black cotton soil and red soil. As we know, in a black cotton soil, it's rich in clay and silt and clay content. Okay, where the silt and clay contents are more, okay, it take more compaction. At the same time, we can improve the engineering property. At the same time, we can reduce the permeability because of soil type. Okay, and nothing but a type of soil. And if you go for the red soil compared to there is the black cotton soil, okay, we can expect there is a less engineering property when you go for the compaction compared to black cotton soil. Okay, in dry state. Okay, and voids also we can expect less compared to black cotton soil. Okay, means that is the type of this soil. At the same time, if you can go for the sand and clay content. Okay, in a sand, you can see we can't expect any that is the clay content, the silt content. You can't go for the too much compaction, especially in a sand. Okay, and in a clay form, in a clay you can compact it very well. You can compact. Okay, you can minimize the that is the volume, you can decrease the volume. Okay, at the same time you can increase the engineering property also. There is the nature and type of the soil. And some of these soils you can expect there is an um there is the silt binding capacity, cementous content also we can expect, and water content at the time of compaction, and moisture content at the time of compaction. How much water we are adding to the soil to compact? Usually in a compaction they go for the 0.5%, 1%, 1.5%, 2%, 2.5, 3.5, like that. Simply they can't put it 10%, 20%, 30%, they can't put it. Okay, they increases the certain intervals, usually 0.1, 1, 1.5. That is the usual intervals they maintain. After inserting the water and compacted, they can expect a good result. Means how much water or moisture content are present in a soil. That is also one of the factor in a compaction. And the site condition, what is the site condition? We already discussed, okay, in North Karnataka and South Karnataka and Malnad region, and especially Bihar and Rajasthan. Okay, we can expect there are different types of, that is soils we can expect. Okay, and especially Nepal, those are Uttarakhand. Okay, we can expect there is a landslide in this type of area. Okay, and Kodagu, Chikmagalur, we can expect there is a landslides. Okay, in these type of area, how we can compact it? Weather is also, there is the climate also important factor. Here, what is the rainfall data? If rainfall data is too high, then we can't go for the compaction. That's the simple type of compaction. We have to use, there is a different types of platform we have to use it. And site condition, what is the site condition? Whether there is the hilly area or slopy area or flat terrain, what type of terrain we can expect. Okay, that is also one of the parameter. And thickness, layer thickness, what is the layer thickness? Especially in a road construction, flexible or rigid pavement road construction, we can expect these kind of, that is the parameters. In a layer construction, in road construction, we can expect there are the different types of layers, especially in a flexible pavement. In highway engineering, I think that concern course coordinator, they discussed flexible pavement means number of layers, rigid pavement means it is restricted to 2 to 3 layers. Means in a flexible pavement there are the number of layers are there. Okay, at least 6 to 7 number of layers. Each layer they require the compaction, means each layer, we have to give the, that is the 0 watts, that is the layer, then we have to go for the compaction. When you go for the compaction for the each layer, there are the different types of layers are there. One layer is completely covered with the coarse aggregate, one layer is completely covered with the soil, and another one is layer is completely covered with the bitumen, like that. When you go for the compaction, we can increase the different layer, different compaction is required, different weight of compaction is required. For the coarse aggregate, we are using number of passes are different, weight of, that is the roller, is different. When you come to soil, number of passes are different, weight of compaction is different, like that. And next one is the compactive effort. The compactive effort, type of plant, that is the weight, vibration, number of passes, we already discussed. Depend upon the, that is the site condition, depend upon the soil condition, depend upon the nature of the work. Okay, they give the number of passes are different. For the road construction, number of passes are different. For the residential construction, the number of passes are different. Like these are the factors affecting the compaction. And next one is benefits of compactions. What are the advantages we can expect? What are the benefits we can expect? First one is increase the soil strength. Obviously, when you go for the compaction, we can improve the bearing capacity of the soil. Suppose if you want to construct this, there is a building in a natural soil and another one is compacted soil. What are the difference you can see? When you want to construct these, there is a building in a natural soil. Obviously, it's a undisturbed manner, and we can expect the voids also. When you constructed the ground floor and first floor, you can't expect any reaction. When you go to second, third, fourth, fifth, then you can expect there is a settlement. Whether there is the unequal settlement or a complete settlement, there is a different, but settlement we can expect. When you go for the compacted soil, okay, you can't expect any settlement over there. You can't expect any settlement, means you can improve the bearing capacity of the soil. And next one is increase the load bearing capacity of the soil. What I given the example, if you apply the load like second floor, third floor, fifth floor, fourth floor, sixth floor, like that, if you applied the load, then you can't expect any settlement over there. You can improve the bearing capacity of the soil when you go for the compaction. And reduction in settlement, then obviously when you go for the compaction, voids, you remove the voids, air voids as well as the water voids, and you can create a hard or rigid surface. Then obviously there is an settlement is completely less. And reduction in the flow of water, obviously permeability is very very less, because you are removing the voids. There is no chance of water is flowing from the one point to another point. It takes some time. It is a media, so soil is also one of the media. It transfer the water from the one point to another point. When you compact it, there is a different history. There is a different that is the thing. we can expect there is a water is flowing in a small percentage. At the same time, we can improve the engineering property and a reduction in the soil swell expansion, especially black cotton soil. It is called as a problematic soil, or it is one of the problematic material in the civil engineering field. Why anyone? Why black cotton soil is a problematic soil?
So because of low bearing capacity.
Sorry,
So because of low bearing capacity.
low bearing capacity, and one more reason, technical reason.
When the water is more, it swings, and when the water is less, it bulks. And when the water is more, and when the water is less,
That's correct.
comes to the normal state.
Compared to red soil, black cotton soil, it absorbs the more water during the water time or rainy season, for example. It absorbs the more water. Then obviously we can improve that, increases the volume. At the same time, during the summer, okay, it extracted the water, means water is evaporated or moisture there is the contents or absent. In that time, it reduces, its volume is reduced, it shrinks. Swell and shrinkage property we can expect the more in a black cotton soil. When you go for the shrinkage as well as the swelling property in a black cotton soil, then obviously we can expect the cracks in a structure. So that is the one of the reason, that is the major reason. Okay, so they call it as a problematic material or problematic soil in a civil engineering field. When you go for the agricultural view, that is good, but in a civil engineering structures, they call it as a problematic material because of nature. Okay, so when you go for the compaction for the black cotton soil, when you go for the compaction, obviously we can't expect the soil swell because you are removing the voids. There is a no chance, there is a percentage is very less when water is getting to the soil media when you go for the compaction. And another one is compaction as well as the increases the volume, then you don't have any chance, especially in a black cotton soil, because main thing is happened because of there is the water content, water flow in a black cotton soil. You are minimizing the water flow in a black cotton soil, then you can't expect any shrinkage as well as the swelling property because of compaction. Compaction is also one of the natural method of soil stabilization and the ground improvement. Okay, increases the slope stability. How we can increases the slope stability? Nowadays, you can see, especially Madikeri and Kodugu, Chikmagalur and Uttarakhand and some of the places we can see there is a landslide or nothing but a slope stability, improper slope stability. How we can give the slope protection during the compaction? Obviously, see, when soil is in a free form, when voids are present, waters are easily penetrated into the soil mass, that is the void mass, and it create a voids. It create a voids, and at the same time, soil as well as the waters are flow equally. Then we can't expect any stability to the structure. When you go for the compaction for the slopy area, then you are minimizing the voids. Then at the same time, you can't expect any water particles or get into the soil mass, means you can improve the slope stability. And another way is you can improve the c and pi value, that is the cohesion and angle of internal friction of the soil. When you compacted the soil, you can improve the c and pi value. Then obviously we can improve the engineering properties of soil in slope stability. And reduction in frost air damage, means obviously voids are less, you can't expect any water content. These are the benefits or advantages of compaction. In examination, they will ask define compaction and mention or list out the advantages of compaction. Okay, you can expect 4 to 5 marks. Why compaction is important? We are telling compaction objective, we discuss compaction objective, factor affecting, these are the things. Why compaction is necessary in a technical way? Compaction is increases the shear strength of the soil. Obviously, shear strength parameters in examination, especially in a lab, viva, they will ask, okay, what are the shear strength parameters? C and pi values are shear strength parameters through soil, which is important if soil being used to retain the water, such as would be required for the earthen dam. Compaction can be prevent the buildup of a leakage water pressure that causes the soil to liquefy during the earthquakes. Means compaction, it can prevent there is a water pressure or water flowing and causes the liquefaction in during the seismic zones. Okay, so this is the reason compaction is important. One thing is we can improve the engineering property naturally. See how we can improve the engineering property. There are the many ways are there. If you add any material or any chemicals, you can improve the engineering property. Okay, but in a compaction is the natural process. When you go for the natural, there is the compaction. You are not affecting any groundwater table. You are not affecting any natural. There is the climatic or environmental things. So compaction is the one of the natural method. At the same time, we can increase the engineering properties of soil. Okay, and next one is there is the with the various types of there is the compaction equipment, especially for the building projects. For other projects, there are the different compaction equipments are there. For example, dam construction, road construction, there are the different equipments are there. But similar, there is the equipments are also we are using for the building projects also. First one is the smooth wheel. There is the roller and ship-footed roller and a pneumatic roller, vibrator roller, rammer, and vibrator plate compactor. Usually, these are the different types of compaction equipments that are used for the building project. First one is the smooth wheeled roller. Obviously, you can see these kind of there is the equipment in daily, especially in the road construction and building construction. Also, you can see this kind of equipment. That is the machinery. Self-rolled or tolled steel roller ranging from 2 to 20 tons. Means that is the weight itself. It varies from 2 to 20 tons. Some of the road project they require more than 20 tons, around 30 tons, 50 tons, 60 tons, and some of the buildings, okay, it required 10 tons or 12 tons like that. Depend upon year also depend upon the project and depend upon the site as well as the soil condition. They increases the weight at the same time they decreases the weight. Okay, this are usually the weight varies from 2 to 20 tons. Unsuitable for well grained sand and gravel. Means where we are using these kind of roller means that is the well grained sand and gravels, means where there is the coarse aggregates or presence or more, especially boulders. Okay, boulders and we can't expect any there is the soil particles. There is the 20% of soil particles you can expect, not 100%. Okay, in those kinds of there is the area you can use these kind of there is the rollers. And I already discussed silt and clay content of low plasticity, where the low plasticities are present. Okay, we can use this kind of material. And unsuitable for uniform sand and silty sand and soft clay, where we can't use this kind of there is the material. Means uniform sand means completely there is the sand layer. For example, Rajasthan, there is the completely desert like a sand layer. We can't use those kind of area. And silty sand, there is the Putenali Lake side. Okay, in Putenali Lake, we can't use it. This kind of there is the vehicle. And the soft clay, where there is an adjacent to the lake, a sediment soil, we can't use these kind of situation. There is the field condition. We can't use these kind of there is the smooth wheeled roll. And next one is the grid roller. Grid roller means you can see in the diagram there is a completely box shape. There is a grid shape you can expect. Okay, and in soil also see in below the machinery you can see there is an impression, that is the box impression. Okay, the turn unit are with a roller of 30 to 50 bars, means they are using the bars in small opening for the grid purpose. Small there is the 30 to 50 bars with a space between the 90 to 100 means there is the space is around the 90 to 100 the weight is around 5 to 12 tons. Okay, means they given the what is the weight of there is the equipment, that is the machinery, and space also they given, and what is the thickness of there is the bars also they given in the um, mentioned here. And where it is suitable, it is suitable for the well grained sand, soft rocks, stony soil with a fine fraction. Means well grained sand, especially for the construction of grounds, or if you want to compact at the football ground or any cricket stadium. Okay, they are using these kind of compaction rollers. And soft rocks, especially for the limestone and sandy stones are present. Okay, they are using these kind of that is the machinery with a fine fraction. Suitable for uniform sand and silty sand and very soft clay. Okay, unsuitable for the uniform sand. I give an example like Rajasthan, Telkadu, and these areas completely covered with that is the sandy area. We can't use this kind of that is the machinery in those kind of in those fields. And silty as well as the sand and soft clay. I given the example known near Putanelli Lake or a lakeside sediment soil. Okay, in these area we can't use this kind of that's the machinery. Sheepfoot roller. See in a diagram itself, in a roller you can see there is a small projection, small projection. Okay, we can expect the more that is the compaction, especially these kind of equipment. We call it as a sheepfoot roller. Okay, also known as a tamping roller. Self-proper or covered unit with the alloy drum fitted with a projecting club shaped fit. Okay, means small that is the projection we can expect in a smooth roller in a diagram. Can see the weight of the machinery usually varies from 5 to 8 tons. Okay, it is suitable for the fine grained soil and sandy gravel with a less than 20% of fine, hence where the silt contents are more, especially if you want to construct the there is the building or road near Putanelli Lake. Okay, you can go for this kind of this, that is the machinery. And where unsuitable, where the coarse aggregates are present, especially the flexible pavement road construction, that is the gravel site. Okay, boulders, um, you can go for you can't go for this kind of equipment. And uniform gravel means completely boulders, especially in a road construction we can expect a very coarse soil as well as the uniform gravels. We can't expect this kind of machinery in road construction, especially flexible pavement construction. And mining area also we can't expect. Pneumatic tired roll, usually the container of two axle with a rubber tire wheel. You can see here a tire roll. At the same time, next to that diagram, you can see here in a small pic. We can see there is the first one, smooth wheel roller. Also, we can see here. Okay, the wheel aligned to give the full width of roller track. You can see there is the complete there is a width is covered with the roller. The dead load had given the mass of 12 to 40 tons, means that is the weight is more here. See in the back side we can see there is a smooth one, smooth roller, and the front side that is completely with the help of the tire. Okay, now we can see that load it varies from 12 to 40 tons. Where it is suitable, most coarse and fine soil we can use this kind of material, and suitable for the very soft clay and highly variable soil we can use this kind of that is a roller, especially road construction. Okay, road after the finishing, after the placing of bitumen and tar, we can go for the these kind of that is the machineries to give the level and proper surface to the soil. At the same time, that is the bitumen surface, we can go for this kind of that is the roller. And vibrating tables. Vibrating table, it is not heavier like last few equipments. It is a smaller roller, and range from hand grain machinery to larger roller combination, and suitable for the most soil with a low to moderate fine content, suitable unsuitable for the large volume of work and wet clay soil. Means it is unsuitable for the large volume. For example, if you want to construct a road, okay, you can't go for this kind of there is a machinery. If you want to construct a bridge or dam, you can't go for this kind of equipment, where the parking places and footpaths. Okay, footpath, this area you can go for these kind of machineries. And where the completely wet clay soils, for example Putanelli Lake, if you want to compact near Putanelli Lake, means it is not suitable. And suitable for the most soil with a low moderate fines, means normal soil it's available in the field, we can go for these kind of there is the machineries. Okay, and powered rammer also called as a trench hammer. See, you can see it is it's jump automatically, and at the same time in a orange color you can see there is a spring action. Okay, it jump at the same time with the help of heavy weight it compact up. Okay, and guard pneumatic there is the tamper suitable for the trench and backfill work in a confined area where we can't go for with the help of the rollers. We can use these kind of machineries. Obviously we can't use this kind of equipment for the large volume of work, dam construction, road construction, a field construction, any heavy equipment, heavy field construction. We can't prefer this kind of equipment. Okay, any doubts, students? Any doubts, students? Any doubts?
No, sir.
No, sir.
See, in examination, you can expect define compaction. What are the objective of compaction? What are the factors considered for selection of compaction? And what are the advantages and disadvantages of compaction? And next one, what are the machineries are used for the compaction? These are the things they may ask in examination. And one more. The next one, what is the principle of compaction? Compaction is measured relatively in the term of dry density. It means we can calculate the compaction with the help of dry density only. Means gamma d value. In a first model we discussed that the gamma d value. The increases the dry density of soil brought by processing of compaction. How we can increases the dry density means with the help of the compaction we can improve the dry density. Only that is the only way how we can improve the dry density. With help of the compaction we can improve the dry density value. Okay, means this is also one of the question in your competitive examination, how we can improve the dry density value, compaction, permeability, consolidation. Like this, there is the compaction is the actual correct answer. We can improve the dry density of soil. Okay, and mm, dry density of compaction, and we can minimize the moisture content. Okay, for the given amount of compaction there is an exist of each soil of a moisture content. The term is called it as an optimum moisture content. At the same time we call it as an optimum water content also. Means how much we can add the water, how much we are adding the water, it reached the maximum level, that is the optimum level, there is a peak level. Then if you add any water, any amount of water to the soil, it can't withstand, it can't withstand, it is the stagnant. Okay, then that point we call it as the peak point, we call it as an optimum value. Okay, that is the optimum water content, optimum moisture content. They will call in some other textbook they will call it as an optimum moisture content. In some other textbook they call it as an optimum water content. Okay, and water to be added for the lubricant the contact surface of soil particle to improve the compressibility of the soil matrix. Why we are adding the water only means it create a lubricant for the soil proper soil, and it compact, we can improve the compressibility of this soil. Increases the water content, increases the dry density, we can improve. This is the usual principle of compaction. Okay, any doubt, students? Any doubt with respect to today's class and yesterday's class? Any doubt, students? USN 1 students, at the end of the
Present, sir.
class, don't leave in between. Don't leave the class or don't exit the class in between, please. USN 1,
Present, sir.
2,
Present, sir.
3,
Present, sir.
4.
Present, sir.
And yesterday I shared the assignment questions through Google Classroom. Okay. I think you received the mail also. Kindly download the questions and what are the answer those questions. Okay, that's completely problem. Answer those questions in A4 size sheet. Afterwards, scan that sheets and upload in Google Classroom. File should be your name as well as USN. I shared what is the format also in a chat box. I will text it. File file name should be names in capital letter as well as USN underscore module 1. File name should be like this. Okay. When can I expect the complete assignment with respect to module number 1? Okay, I will give 2 days time. Okay, 25th, because you are not discussed the that is the date and timings. Okay, 25th within 4:30 you have to submit. Okay, 6 USN 6,
Present, sir. Present, sir.
USN 7,
Present, sir.
USN 9, USN 10,
Present, sir.
USN 12, USN 13,
Present, sir.
USN 15, USN 16,
Yes, sir. 16.
USN 17,
Yes, sir.
USN
Present,
13,
sir. 7.
USN 13, USN 19,
Sir,
Present, sir.
18.
18, okay.
19 present, sir.
19, USN 20,
Present, sir.
USN 21, 22, USN 22,
Present, sir.
USN 23,
Present, sir.
USN 24,
Present, sir.
26, 27,
Sir.
29,
Present, sir.
30,
Present, sir.
31, 32, 33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38, 40,
Present, sir.
41,
Yes, sir.
43,
Present, sir.
44,
Present, sir.
45,
Present, sir.
47,
Present, sir.
48,
Present, sir.
50,
Present, sir.
51, 52, 53, 54,
Present, sir. 53 present, sir.
54, 55,
Yes, sir.
56,
Yes, sir.
57,
Present, sir.
58,
Present, sir.
59, 61,
Present, sir.
62,
Yes, sir.
64,
Present, sir.
65, 66, 16 series 49, 18, 17 CV 18, 44, 17
Yes,
CV
sir.
44,
Yes, sir.
17 CV 58,
Yes, sir.
17 CV 67,
Present, sir.
400, 401, 402, 403, 404, 405,
Yes, sir.
Students, any doubts with respect to today's class? Any doubts?
No, sir.
Any doubts? If you have any doubt, please discuss with me. If you have any doubts, please, it's my request. If you have any doubt, please discuss with me, and we can, if you want, once again, we can repeat the portion. Okay. If you have any doubt, we can discuss. Okay. And I already informed, I uploaded there is the question assignment question in your Google Classroom. Okay, please download the questions and write it as far as possible early, and within today's 25th, within 4:30 you have to complete the assignment, and you have to upload in Google Classroom. Okay, any doubts? Any doubts?
No, sir. Sir, 21 present.
21. Okay, thank you, Pa. Thank you.
Thanks.